All right, this is 11.4 on compound events where we use the addition rule of probability. We will now look at two types of compound events. In the previous section, we worked with probability of multiple events that were and statements. What is the probability of A and B occurring? Now we'll look at or statements. What is the probability of A or B occurring? There are two ways that this can happen. Let's consider finding the probability of students in your class with long or short hair. The students will have one or the other. Since the two events will not overlap, they are considered mutually exclusive. And so there's an example here of a Venn diagram where you have long hair in the green circle, and then in the blue circle is your short hair. You have one or the other. So what we do is we just add the two events together. If we have inclusive events, then they will have long hair or blue eyes. So those could overlap and they're considered inclusive events. So here's an example where you have students who have long hair and blue eyes, and there's that overlap there in the red. To find the probability of an inclusive event, you will need to add the two probabilities and then remove the overlap so you don't double add. So I would highlight the formula here. The probability of A or B is you add the probability of A, so this circle here, plus the probability of B, that circle, and then you subtract the overlap. Mutually exclusive events are ones that they both cannot occur at the same time. So our formula is the probability of A or B. You just add event A probability plus event B probability. Example 3, mutually exclusive events would be rolling a 1 and rolling a 2 on the same roll, as these both can't happen. So find the probability when a number is rolled, you would get the probability of less than a 3. So you could get a probability of a 1 or a 2. So what's the probability of getting a 1? Well, that's 1 out of 6. And the probability of getting a 2 is also 1 out of 6. So then what you would do is you'd add the two fractions together and then reduce it. Example 4, another mutually exclusive event. A group of students are donating blood at a blood drive. A student has a 9 out of 20 probability of having blood type O and a 2 out of 5 probability of having blood type A. These are considered mutually exclusive because you either have O or A, you can't have both of them. So it's asking us what is the probability that a student either has O or A. So these are mutually exclusive. So we have O or A. So we have the probability of O plus the probability of A. So we add up 9/20 plus 2/5. Now what I'm going to do is I'm going to change that second fraction to have the same denominator. So I'm going to multiply the numerator and denominator of the second fraction by 4. So 9/20 plus 8/20 is 17/20. Each student casts one vote for a senior class president. Of the students, 25% voted for Hunt, 20% voted for Klein, and 55% voted for Villa. A student from the senior class is selected at random. Why are these considered mutually exclusive? So either you're going to get to vote for Hunt or Klein or Villa. So you get one vote, which means there's going to be no overlap. They're all individual people. So what is the probability of Klein or Villa? So we add Klein, which is 20%, and then Villa of 55%. So 0.20 plus 0.55 is 0.75 or 75%. Okay, now we're going to change to inclusive events. That's where there's going to be that overlap. So when we do our two events, we have to subtract out the overlap. So this is that overlap. Example 6, inclusive events. When rolling a number cube, the outcome of rolling an even and rolling a prime number are not mutually exclusive. And the reason why is the number 2 is in both of them. So this first event are all the even choices, so 2, 4, and 6. And then the second circle are our prime numbers, 2, 3, and 5. And notice the overlap of the number 2 is in both. So it's asking us then to find the probability when a number is rolled that you'll get a probability of an even or a prime. So we're going to use our formula up here in the green. So we say the probability of even plus the probability of being a prime number, and then minus the probability of being even and a prime number. So this first circle is 3 out of 6. The purple circle, the primes, again, 3 out of 6. And then the overlap, 1 out of 6. So we have 3 out of 6 plus 3 out of 6 minus 1 out of 6. And then we simplify. So 3, 6 plus 3, 6 minus 1, 6. When we add those together, we get 5, 6. Example 7, inclusive events. Find the probability when a number cube is rolled that you get an odd or a number greater than 2. So our first circle, event A, will be odd numbers. The second circle will be numbers greater than 2. So let's go ahead and write those numbers in. So 1, and then 3 and 5 are odds, but they're also greater than 2. And then we have 4 and 6. And the one number we're not using is the number 2, so that goes outside. So we say, what is the probability of an odd or a number greater than 2? So you add the probability of the odd plus the probability of a number greater than 2 minus the probability of odd and greater than 2. So our first circle has a 3 out of 6 probability. Our purple circle has 4 out of 6. And then the overlap, the intersection, is 2 out of 6. So we go ahead and substitute those fractions in. So 3 6 are odd. 4 out of 6 are greater than 2. And then 2 numbers out of 6 are odd and greater than 2. And then we go ahead and add these fractions together. So 3 plus 4 is 7, minus 2 is 5/6. All right, our next inclusive event is we have a deck of cards, and there's 52 cards in the deck. What is the probability of drawing a king or a heart? So a king will be the first circle. A heart will be the second circle. And then the overlap are the cards that are both a king and a heart. So if we think of the deck of cards, there are 4 kings in a deck. And then there are 13 hearts in a deck. And then there's 1 card that is a king and a heart. So I'm going to put that in the middle. So that means there's 3 left in the pink and then 12 in the green. So let's go ahead and answer the question. The probability of a king or a heart will be the probability of a king plus probability of a heart minus a king and a heart. So our pink circle's probability is 4 out of 52. The green circle, there are 13 hearts out of 52 cards. And then the overlap here in the brown is 1 card out of 52. So 4 kings out of 52 plus 13 hearts out of 52 minus the overlap of the king of hearts. And then we add those fractions together. So 4 plus 13 minus 1 is 16 out of 52, which reduces down to 4/13.